Let us look at a more in-depth example of using the definition of quality, as well as our use of specific volumes. Say we have a pressure cooker operating at 110 degrees centigrade that has a volume of liquid to volume of vapor ratio of 0.2. And this pressure cooker is heated until the pressure reaches 250 kPa internally. We want to find our final temperature and the final percent vapor. To begin, we'll always write out our state variables. At state 1, we have a temperature of 110 degrees centigrade. And since we have a liquid and vapor existing simultaneously, we know we're saturated, such that our pressure is equal to our saturation pressure corresponding to T1. That is, our pressure at state 1 is 143.3 kPa. At state 2, we know our pressure is going to be 250 kPa. Since we know that the volume of our liquid to our volume of our vapor at state 1 is equal to 0.2, we can express this in terms of mass in our specific volumes. That is, the volume of our fluid to that of our vapor is equal to 0.2. Or the volume of our fluid is equal to 0.2 times the volume of our vapor. Now in terms of masses in our specific volumes, the mass of the fluid times our saturated liquid specific volume is equal to 0.2 times the mass of our vapor times our saturated vapor specific volume. Recalling the definition of quality and eliminating the mass terms within, we can say our quality at state 1 is equal to mass of our vapor per the mass of our fluid plus the mass of our vapor. This would be equal to the mass of our fluid times our saturated liquid specific volume per saturated vapor specific volume per the mass of our fluid plus the mass of our fluid per 0.2 times the quantity our saturated liquid specific volume per our saturated vapor specific volume. Or this would be equal to the mass of our fluid per 0.2 times the quantity of our saturated liquid specific volume per saturated vapor specific volume per the mass of our liquid times the quantity 1 plus 1 per 0.2 times the quantity of our saturated liquid specific volume per our saturated vapor specific volume. Or our quality at state 1 would be equal to 5 times the quantity of our saturated liquid per our saturated vapor specific volumes per 1 plus 5 times the quantity of our saturated liquid per our saturated vapor specific volumes. Consulting table B.1.1, we see that our saturated liquid specific volume corresponding to 110 degrees centigrade is 0.001052 meters cubed per kg, and our saturated vapor specific volume corresponding to 110 degrees centigrade is 1.21014 meters cubed per kg. If we make these substitutions into the expressions for nu sub f and nu sub g in our expression within quality, we see our quality at state 1 is equal to 0.00433, or 0.433%. Now that we have our quality at state 1, we can determine our specific volume of the system. And since this process is isochoric, that is, the volume of our system is not changing. It is the pressure cooker. It is a rigid vessel. We can then determine the quality at state 2. We can do this by relating our specific volume at state 1 being equal to our specific volume at state 2. For us to do this, we first have to determine our specific volume at state 1. Our specific volume at state 1 is equal to our saturated liquid specific volume plus our quality times the difference of our saturated vapor and saturated liquid specific volumes. That is, nu sub 1 would be equal to 0.001052 plus 0.00433 times the quantity 1.20909 meters cubed per kg. And our specific volume at state 1 is 0.00629 meters cubed per kg. Now, our specific volume at state 2 is equal to that at state 1. As we noted before, this is an isochoric system. Our volume at state 1 is equal to volume at state 2. And we have a constant mass system. Therefore, nu 1 would be equal to nu 2. Since our specific volume exists between our saturated liquid and our saturated vapor specific volumes taken at 250 kPa, T2 is equal to our saturation temperature corresponding to a pressure of 250 kPa. And our temperature at state 2 is 127.43 degrees centigrade. And lastly, our quality is found at state 2 by taking nu 2 minus nu sub f per nu g minus nu sub f. And this is 0.00629, which was equal to our specific volume at state 1, less our saturated liquid specific volume corresponding to a pressure of 250 kPa, which is 0.001067, per nu sub fg, taken at 250 kPa, which is 0.71765 meters cubed per kg. Thus, our quality at state 2 has increased to 0.00728, or 0.728%.